Problem 45, jump came 2. So we are giving a array. So here it means we are having array nums, and we are starting at the first position index 0. So this 2 means we can jump maximum to 2 steps and minimum like 1 steps. Because if we stay at the original position, we didn't jump, we can never reach to the end. Yeah, so this means we can jump at least 1 position to 2 positions. If we jump 1 position at 3, so for the next step, we can jump maximum 3 positions. So from here, 1, 2, 3. Yeah, we jumped to the end point. This means we just need 2 jumps. So for example, this one, the first position is here. So for the first step, we jump to 3, and in the next step, we can jump 3 jump. We can jump 3 steps. It means 1, 2, 3. Yeah, we go to the end. So how to solve this problem? Let me go to the whiteboard first and then go to the code editor to finish the coding. So for example, here, if we are starting at this position, the first position here, it means we need to have a range for our stems. So for the first jump, we can jump like 1 to 2 jumps. So for the first jump, it is here at this position. If we jump 2 steps, it goes to here. It means for the first jump, we have a range of 3, 1. This is our next starting point. So this is our first starting point. It is the first position number 2. If we are starting at the if we started our first jump, we go to the next point. It is 3 and 1. As we can see, this is our next step. If we go to 3 and 1, what is our next step? So here, it means we can jump 3 steps. So it means we can jump to the end. We just need to go out of the loop. Yeah. So it is just means just two steps we can finish all of them. So the idea is for each of the step, how many rings we can hold the positions. So this is the first jump. This is the second jump. We have 2 positions. The first time we have 1 position. So after the first jump, we have 2 positions, and then we jump, go to the last position. We just need to, return our result. So here I will use R pointer and L pointer, both start from 0. And R pointer will also start from 0. The L pointer and R pointer means the range, including L and R. The range we can hold at each step. So for the first step, we are L pointer and R pointer equal to 0. It means we are at the first index position number 2. After that, we will jump. So after jump, we will have L pointer should be 1, and R pointer should be 2. Yeah, so this is a pointer. This means we are at this range. So at this range, we get our furthest point. If our furthest point goes to here, it means we find the last point. We just need to return. Now let me go to the code editor to finish the coding of this idea. Yeah, as I said, I just need a L pointer and R pointer and result. Yeah, and point is 0 and 0 for both L and R pointers, and the result will also be 0. I just needed to return the row. I didn't find the last point, so while the R pointer is less than nums L minus 1. Here I used minus 1 because I didn't find the last point yet. If I find the last point, the R should equal to then nums minus 1. Yeah. And then I will define a furthest. So this means my furthest point I can reach for each of the jump. Yeah. So for the first step, so my furthest is 0 before I jump. Now I will check for my range. So my range is L to R. As I said before, the R should be included. So here should be R plus 1. So this is the first step. So what is the first point, furthest point we can get? We can use R max and nums I plus I. Yeah, this means if we are at the first position or at the second position, for example, if we are at this position, it means the furthest point is 3 plus 1. Yeah, so the index goes 4. Yeah, so this is the index 4. It means we can go here. So this means the furthest point. It is mentioned here. So it is the nums I plus j, and this j maximum to nums I. So this is why I can use nums I plus. So the j is nums I. So I is my initial position. So this is why I can use this one to get the furthest. After that, my result should plus 1 because I used one step, and the R pointer should equal to the furthest because the R pointer should always be the furthest one, and the L pointer should shift at least 1. Yeah, so this is because here mentioned it is guaranteed you can reach nums n-1. It means the L pointer can always be saved. There's no conditions of like in between. There's always zeros. We cannot jump anymore. So there's no such conditions. This is why the L pointer can always plus 1. Yeah. Otherwise, we cannot reach the last point. So because it is guaranteed plus 1. Yeah. Now let me try to run it to check if it can pass to the testing cases. Yeah, if we don't have a dead loop, it should be okay. Yeah, it seems okay. Now let me submit it to testing cases. At the same time, the time complexity is O(n) because we just used one loop to find to get the result. Yeah, this number n 10 to the power of 4, it seems okay. So why? So because here, while we are shifting the R pointer, the L pointer also shifted. Yeah. Let me check the time complexity. So this means while for each of the step, I think it's not definitely not O(n). So here for each of the steps R pointers, if there are some points like 1 1 1, yeah, we have a lot of ones inside. So for each of the step, yeah, for example, here is L pointer and here is R pointer. L pointer and R pointer start from the beginning. Yeah, so for the first step, we know L pointer goes to here, right? The second step, L pointer and R pointer goes to here, and the third step, and finally. So how many steps? It is still O(n). That is why no matter uh, no matter how big, yeah, how difficult it is to read, the time complexity is always O(n). So yeah, this is why, because for each of the step, the L pointer and R pointer should shift at least one position. So sometimes the R pointer will shift too many positions. It is less than O(n). But basically, yeah, the time complexity is O(n). Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. Bye.